Okay, so today we're doing rotations and congruence transformations. So the first little bit is mostly just information. So this is what all we're doing. We're performing rotations, compositions with rotations, rotational symmetry, identify congruent figures, describe congruence transformations, and then use theorems about congruence transformations. So a rotation is a transformation in which a figure is turned about a fixed point, and it's called the center of rotation. So this would be my center of rotation because I will be rotating around it. It is a rigid motion, and if you recall, a rigid motion means that the figures stay congruent. The rays that are drawn from the center to the point, from here to here. So I would draw this ray to my figure. Then I would draw this ray to my figure. That would be my angle of rotation. All right, so here are your rules for rotations. So when you rotate 90 degrees, they switch places and the y will become negative. For 180, they just simply become opposite of what they already are. And for 270, they switch places. And now the second one will become negative or opposite of what it is. Also keep in mind that these are all rotating counterclockwise. So keep in mind that a 90-degree clockwise rotation is the same thing as a 270 degrees counterclockwise. So if I were to go 90 degrees this way, which would be clockwise, then it is the same thing as rotating 270 degrees counterclockwise. So next time in class, we'll discuss rotating around a point that's not the origin. So these rules only apply when we're rotating about the origin. All right, so we're going to graph the image of the polygon after the rotation of the given number of degrees. So let's do, so we have J, K, L, M. So those are our points. So we're going to rotate 180 degrees. Well, remember to rotate 180 degrees. Actually, I'm going to use X and Y. I like X and Y better. So that just means that the points will stay in their respective places. They just become opposites of what they already were. So for example, our points for J, K, L, and M are, these are their locations. So basically, if I just change their signs, I get my new points. So this would become from -2 to 4 would become 2, -4. So go over 2, down 4. So that would be J prime. This one would be +5, -1. So that would be K. This would be 2, 2. So 2, 2. And M would become -1, -1. So -1, -1. So that would be M prime. And then, of course, I would connect them. And that would be your points. So you would just switch them around like so. Oops. All right. Same thing over here. We've got your original points. We're rotating 90. To rotate 90, oops, that's no good. To rotate 90 degrees, let's go back here. So to rotate 90 degrees, the points will switch places. So Y, X, but the Y will change signs. So here, this one would become -5, -1. So I'd go 2, 4, 5, -1. So that would be S prime. This would become 0, -4. So 0, -4. That would be R. And then this one would become, so they switch places. So that would become -1, -5. So -1, -5. That would be T prime. And then we would connect them. And that would be your rotation for 90 degrees. And the last one here would be to rotate 270. To rotate 270, they trade places, but this time the x will become negative. So I would rotate. So they switch places. So this would be 4, -1. So 4, -1. So that would be a prime. And that's a prime. They switch places. So 3, -4. So 2, 3, -4. They switch places. 1, -3. They switch places. 2, -1. So it would look something like that. And then, of course, there would be your points right here. So that would be what they changed to. So mine doesn't look quite as good as theirs, but it's there. All right. Number 4. This time we're going to graph an image of a segment, and we're going to reflect it, and then we're going to rotate it. So to reflect over the x-axis, x stays the same, y becomes opposite, and then to rotate 180 degrees, they do not switch places, they just simply switch signs. So I would do, so you have your original, and then they flip over the x, so the x stays the same, so -4, and then the y becomes -4, so there would be m prime, -1, and then the y would come up here because it would become +1, so that would be m prime, n prime, and then to rotate it around 180 degrees, that means it's going to have to rotate around. So now they stay the same sign, or they stay the same order. Now they simply just change signs. So -4 becomes +4, +4. So there's m double prime. -1 becomes +1, and +1 becomes -1. So that would be n double prime. So that would be your rotation. So reflect, then rotate. So there's your m's and your n's. All right. Rotation 90 degrees about the origin. So now we're going to rotate 90 degrees about the origin. So 90 degrees about the origin. Remember the rule is, if you don't remember, go back to the front page, 90 degrees rotation. They switch orders. So they switch order, and the y changes signs. So if I go here, so they have to switch, so they trade places. So it will become +1, -2. So +1, -2. And they switch places. So that would be -1, +3. -1, +3. That would be n prime. And then to translate, so now we're just going to slide it around. So there's your next point. So we go from, oops, let me finish drawing that line segment there. Oops, a little crooked. All right, so 3. So I want to add 3 to this. So +3, or no, wait, sorry, +2. So I'm adding 2 to the x's. So +2 would be 3. I'm going to subtract 3 here, so that would be -5. So 3, 1, 2, 5. So there's m double prime. And add 2 here would be 1. And to subtract 3 here would be 0. So 1, 0. So that would be n double prime. And it would go through there. So these are pretty crazy lines all over the place. All right. And last one here is to reflect, or sorry, to rotate 270 degrees. So to rotate 270 degrees, they switch places. And then They switch places and the x becomes negative. So you take your original points, and we'll just uncover them all so we can get moving. So they switch places and the x becomes negative. So now I've got 4, -3, and 1, -3. So that would be my n prime. And then you would do flip over the parent function. So remember, the parent function is the one that goes straight through here. So now I want to reflect over that. So now this is going to reflect over here. So the rule for reflecting over that is that your previous points just change places. So if I reflect over the parent, they just switch places. So now these 2 points just trade places. So 2, -3, 4. So there's m double prime. And 2, 3, 1. There's n double prime. And there's your line segment there. All right. So don't forget you can push pause at any time so you can copy what you need to down. All right, number 7. All right, number 7 is to plot the 3 points that are given. So they gave me these 3 points. So I didn't cover them up. So 1, 2, 1, 2, 3. So there's J, 1, -1. There's K, -1, 0. There's L. So I'm going to connect these 3. All right, now the next one, they said to rotate 180 degrees. So to rotate 180 degrees, they stay in the same order, they just change signs. So that would become -2, -3. So just change all their signs. Basically, you keep them and change all their signs. So that makes it a little easier. So -2, 1, 2, 1, 2, 3. So there's J prime. -1, 1. There's K prime. And 1, 0. There is L prime. So now I can connect these. So let's make this red. All right, and then the next one says to reflect over x equals 2. So now go to the x-axis, find 2. So there's x equals 2. Now I want to reflect over that line. So if I reflect over that line, I want to stay the same distance. So I'm 1 away, so I want to be 1 away. So I would be right here. The K is 1, 2, 3. 1, 2, it's going to put me out here, 3. So that would be K double prime. This is L prime, double prime. And then this J here is 1, 2, 3, 4. 1, 2, 3, 4. So it puts me out here somewhere. So J double prime. And then connect those. So it would look something like that. And then there would be your values. So that would be the actual values of the points. So you took it and you rotated it. So this green one got rotated around and then flipped over. Make sense? All right, so let's plot them over here again. So we've got green. So 2, 3, 1, -1, -1, 0. And then let's connect it and let's make it be green. All right, so there's the original. All right, and now let's do red for the translation. So I'm going to subtract 4 from everything. That's X, and I'm going to subtract 4 from everything. That's Y. So 2 minus 4, 3 minus 4. So now we get this set of points. So I've got -2, -1. So there's J prime. -3, 1, 2, 3, 1, 2, 3, 4, 5. I should have stuck with counting by 2s, but I didn't, so it's okay. So -5, -4. Oops, put it one more down. So that would be L prime. And then we'll connect those. So that is nothing but we just backed up 4, dropped it down 4. So backed up 4 and dropped it down 4. And now we're going to rotate 270 about the origin. Remember 270 about the origin. Let's see if we can delete that. All right. So 270 about the origin. So 270 about the origin, that just means that we are going to switch the order and X will change. So flip them around. So this will become -1, 2, -5, 3, -4, 5. So then we will, let's slide that up here. All right, so -1, 2. So -1, 2. So there's J double prime. -3, 1, 2, 3. -5. Did I write that down right? -3, -5. So -3, -5. I think I wrote something down wrong. J double prime, -1, 2. No, that's right. All right, 1, 2, 3, 5. So I wrote something down wrong. So I got 2, 3, -2, -1, -1, 2. So all my J's are good. And then my K's should be 1, -1, -3, -5. Oh, this one should be -5. I wrote this backwards. +3. All right. So -5, +3, which would put me here, which would be my K double prime. And then my L, I got -1, 0, -5, -4, and there should be -4, 5. And I got that one, -4, -5. So there's my L double prime. All right. So yeah, I wrote that one backwards. So be careful. Don't do what I did. So now we can draw those. So now we took the original, we slid it down and over, and then we rotated it 270 degrees counterclockwise. So we went 90, 180, 270. So 90, 180, 270. So it rotated around. All right, so let's talk about some rotational symmetry real quick. Rotational symmetry, it's a figure that can map itself by a rotation of 180 degrees or less about a center. So this would be the center of the figure. So basically you're like turning it, you're rotating it around. This point is the center of symmetry. So note that the rotation can either be clockwise or counter, so whichever way you can turn it. So this, to determine if it has rotational symmetry, yes, it does. You take 360 degrees, you divide by the number of sides when it's regular, so when all the sides and stuff are the same, and you will get that this is 72 degrees. So this has if I took this point right here and I rotated it 72 degrees, I would get there. If I rotated another 72 degrees, I'd get there, another 72, I'd get there, and another 72, I would get there. So every time I rotate 72 degrees, I will get the exact same figure. This one, nope, there is no rotational symmetry there. All right, identify the line of symmetry and the rotational symmetry of an equilateral triangle. So if we have an equilateral triangle, so let's just draw an equilateral triangle. Equilateral means all the sides are the same and all the angles are the same. So line symmetry, so let's do some line symmetry. So we can divide it through here. We can divide it, ooh, what just happened? We can divide it through here, and then we can divide it through here. So it has 3 lines of symmetry. So 3 lines of symmetry. If you can't read my writing, it's this right here. And then the rotational symmetry, well, since it's regular, would be 360 divided by 3, which is 120 degrees. So every time I rotate it 120 degrees, it will have rotational symmetry. All right, so I have something I want to show you. So for example, order 2, if I take this S and I rotate it once, twice, you'll get that it has 2 rotational symmetries. This one would have 3, this one would have 4, and this one would have 8. There are more, but this is what we got. All right, so just real quick, let me show you this. It's just a quick little thing here. So like this one here, so notice there's 1, and then it rotates again, and there's 2, and you can keep up with it by this little tick mark right here. So this little tick mark, how many times does it stop before it gets back to the top? So 1, 2, 3. So it has order 3. So that's how rotational symmetry works. All right, and then there's a little video there. So if you want to open the PDF file that I downloaded with the video, you can click on the link and it'll explain it. All right, so let's talk about what figures are congruent. So to save us some time, I numbered the figures in the picture because it would be easier. So for example, figure 1 is congruent to figure 6. So 1 is congruent to 6. 2 is congruent to 3. And figure 4 is congruent to figure 5. Explain. Let's see. This one, the figure 1 is a reflection. Is this the one that's a no? This one is not the one that is a reflection. This is just a it's a rotation, 180 degrees. And then this one here from 2 to 3. So it's a 90-degree rotation. So if I rotate this 90 degrees, so 90-degree rotation. I'm trying to read my notes. And then this one here, MNOP and ABC, is a translation. So this would be a translation of x minus 2, 5 units left of x minus 5, and y minus 2. So that one's a translation. This one is a reflection over the parent. So this is a reflection over this. So if we drew that line through here, that one here, this is a reflection of that. So that's how each one of these are congruent. All right. So now we've got these 2 figures, and I want to map P to S. So what's going to happen to point P to give me point S? So P has to go to S. So it can't just be a slide, because if it were just a slide, then P would still be up here, or your point S would be. So 2 things are happening. So the first thing we want to do is let's rotate it around. So if we rotate it 180 degrees, we get these points. So if I rotate it, so remember rotating 180 degrees is they just switch signs. So -2, 3. So here's P prime, or sorry, Q prime. So Q prime, so Q rotates to here. R would be -5, 4. 4, so there's R prime. And then your P prime would be -4, 0. So that would be P prime. And then we can draw our lines. All right, so there would be our rotation. So now do you see how I can just drop it down? So now it's just simply going to be a transformation. So we translate by x is going to stay the same. So P goes to S, just like here, P goes to S. So we're just going to drop it down 5 units. And since the x value stays the same, we're not going to change it at all. So that would be that transformation. And then this one here says determine whether the polygons with the given vertices are congruent. So I'm going to just plot the points. So 2, 2, 3, 1, 1, 1. So I have this lovely little tiny triangle. So 2, 2, so this is A, B, and C. And then now I've got 2, negative 2, 2, negative 2, 3, negative 1, 1, 2, 3, negative 1, and 1, negative 1. And now I've got this tiny little triangle here. And they want me to determine if they are congruent. All right. So I see that if I look up here, I notice that the x's are all the same. X is same, x is same, x is same. So x is the same. And I notice that my y's all changed sign. So what rule says they all stay, that when x stays the same and y changes sign? So this is a reflection in the x-axis. So it's reflection in the x-axis. So I noticed that all the x's stayed the same and that all the y's changed. And that's just how you determine it. So just look and see what's happening. All right, so the angle of rotation. So just pick a point. So if I were to pick a point here, so pick the same point in each figure since it's all the same. And then I'm going to draw a line to each one. So from the center of rotation, and I want to map it to here. So what I do know is that this is 60 degrees. So that means this angle here is going to be what? So we look at it and we're like, okay, I go from here to here, and then here to here. So I know it's not 180 degrees, because if it were 180 degrees, it would come all the way here. And it's not. So this is going to be an angle of 120 degrees. So it's a 120 degree angle of rotation. And those are just kind of one of those, I just kind of got to play with it a little bit, because from here to here is 120 because of the vertical angles. Okay. So next time in class, don't forget, we will discuss rotating about a point that is not the origin. And I am sorry these were so long. See you next time.